In this tutorial, I'm going to look at the Poisson distribution. And for illustration, I'm going to use the problem which is appearing on the right there. An automated production process has been experiencing an average of 1.5 breakdowns per day. Assuming that the number of breakdowns per day follow a Poisson distribution, I will find number 1, the probability of no breakdowns, number 2, the probability of 1 breakdown, number 3, the probability of 2 breakdowns, number 4, the probability of 3 or more breakdowns. So to answer question number 1 there, the probability of no breakdowns. No breakdowns, that means we are looking at the probability that x is equals to 0. To calculate that probability, we'll use that Poisson distribution, and we are given that our lambda there is 1.5. And the command that I'll use there is dPois, the one that is the density. So dPois calculates the probability that x is equals to x. So in this case, we are calculating the probability that x is equals to 0. So I will type in my dPois there. Let me just remove the caps. So it's dPois, open parenthesis, and we want to find the probability that x equals to 0. So I put in my 0. Then the parameter lambda we are given is a 1.5 because we are looking at an average of 1.5 breakdowns per day. So we have 1.5. So that's dPois, and it will calculate the probability that x is equals to 0. And it will give us the value 0.2231302. For question number 2, we are looking at the probability of 1 breakdown. So we are looking at the probability that x is equals to 1. So what we have to do is we change where we had the dPois there, where we're looking at 0, we now look at 1. So I'll press the up arrow, then I'll just edit this command. Where I had 0, I'm putting 1. And I'll press enter, then it gives the probability as 0.3346952. For question number 3, we are looking at the probability of 2 breakdowns. That's the probability that x is equals to 2. And for probability of x equals to 2, we use the density again at dPois. So I'll change where we had the 1 there, and I'll put a 2. And the parameter there is not changing, it's still the 1.5. And I'll press enter, and it gives us 0.2510214. So that's the probability that there will be 2 breakdowns. I can also calculate those probabilities in question 1, 2, and 3 using just one command. I can enter where I was entering the value there of the x is 0, 1, 2. I can put a vector 0 to 2, and it will calculate those probabilities. So if I put it as a vector 0, then colon 2, then I will go on and press enter. So it gives us the 3 probabilities. At the first one here, the probability that x is equals to 0. The second one, probability x equals to 1. The third one, this one here, the probability x equals to 2. We now move on to question number 4, the probability of 3 or more breakdowns. The probability of 3 or more breakdowns is the probability that x is greater than or equal to 3. The probability that x is greater than or equals to 3 is equals to 1 minus the probability that x is less than or equal to 2. So what we can do is we can subtract from 1 the sum of those 3 probabilities that I have just calculated there. Or the other option is to use the Poisson distribution function, the cumulative one, the pPois. So the command for that one is pPois q, specify the parameter lambda, then lower tail true or false. And if it is true, we'll be calculating the probability that x is less than or equals to x. If false, we'll be calculating the probability that x is greater than x. So in this case, we can write the probability of x greater than or equals to 3 is probability of 1 minus probability of x less than or equals to 2. So when I type in the command using the Poisson, I'll type in the probability there of x greater than or equals to 3 is 1 minus, and then I type in my Poisson, the cumulative one. Both Poisson is different from the Poisson, the density. The Poisson gives us the cumulative, and I will specify probability x less than or equals to 2. So I put my 2, then the parameter. The parameter there is 1.5, and the lower tail, if we say is true, then it will calculate x less than or equals to. But in this case, what we want is the x less than or equals to 2. And we can write the lower tail equals to true, or we can just leave it like that. Because if we don't write anything on lower tail there, it assumes that it is true. But if we're calculating x greater than x, then we would use a lower tail equals to false. So in this case, we leave it like that, and it will assume that lower tail is true. Then it will calculate probability x less than or equals to 2. So it will subtract that from 1, and we'll get that probability there is 0.1911532. So what we are having there is the probability of 3 or more breakdowns is 0.191153.